Systems architecture or electronic toll collection, cloud application and service IoT system. I'm Dr. William S. Chow. Chapter 1. What is electronic toll collection IoT system? ETC is accomplished by a combination of a camera which takes picture of the car and a radio frequency key computer which searches for a vehicle's windscreen mounted radio frequency identification RFID tag to verify and collect payment, as shown in Figure 1-1. Behavior of ETC cases consists of the following 5 behaviors. The first behavior is registering vehicle account. Each vehicle needs to register to ETC cases system to get this service, as shown in Figure 1-4. The second behavior, sensing information from vehicle with tag. If the vehicle has the ETC tag, then it will use this behavior to collect the information of the vehicle. The third behavior is sensing information from vehicle without tag. On the contrary, if a vehicle has no tag, then it will use this behavior to collect the information of this vehicle, as shown in Figure 1-6. The fourth behavior is inquiring account balance. Each vehicle owner can use this behavior to inquire his account balance, as shown in Figure 1-7. The last behavior is the fifth behavior, recharging account. Each vehicle owner can recharge his account using this behavior, as shown in Figure 1-A. Chapter 2. What is SBC architecture? Usually, a system is very complicated, so it includes a lot of views. There are 2 different ways to model this many views. The first one is called multiple model, such as UML. The UML approach will generate a lot of inconsistency among these multiple models, as shown in Figure 2-5. On the other hand, we will use model singularity approach. Instead of choosing many inconsistent models, this approach will use only one integrated model, as shown in Figure 2-6. Structural Behavior Coalescence, SBC, means to integrate the system structure and system behavior. SBC architecture uses 6 fundamental diagrams to specify and describe a system, as shown in Figure 2-20. AHD, FD, COD, CCD, SBCD, and IFD are these 6 fundamental diagrams. SBC architecture is a single model approach. So we have SBC architecture to generate these 6 views to model a system. Chapter 6. framework diagram or ETC cases. Framework diagram FD depicts the structural view of a system. As shown in Figure 6-1. Presentation layer contains 3 components. Logic layer contains 2 components. Data layer contains 1 database component. Technology layer contains 2 components. Chapter 7. Component Operation Diagram or ETC cases. Component Operation Diagram (COD) also depicts the structural view of a system. As shown in Figure 7-1. For all those components, each component has its own operations and their corresponding input and output data. Chapter 10. Interaction Flow Diagrams or ETC cases. Interaction Flow Diagram (IFD) depicts the behavior view of a system. ETC cases include 5 individual behaviors. Figure 10-1 shows the first IFD of the registering vehicle account behavior. There are 2 interactions in this IFD. The first one is the toll authority actor interact with the vehicle account registering UI component. The second interaction is for the vehicle account registering UI component to interact with the ETC cases database. The second behavior is the IFD of the sensing information from vehicle with tag behavior. Once a vehicle has the tag, so we will use this IFD to catch its behavior. There are 4 interactions in this IFD. The first behavior, the server root will generate the use for VWTD process to interact with the vehicle with tag daemon component. Then the tag reader component will sense the vehicle with tag using the sense tag operation and get the tag information input data. Then it will output the tag information data to the vehicle with tag daemon component. Then the last interaction, then this daemon component will use the SQL insert tag information operation to input the tag information query data to the ETC cases database component. Figure 10-3 shows the IFD of the sensing information from vehicle without tag. Once a vehicle has no tag, then we use the camera to catch the information of this vehicle. They also have 4 interactions. The first one is to fork VWOTD process operation for the server root actor to interact with the vehicle without tag daemon component. The second interaction, the camera will capture the image from the vehicle without tag and input to get the input data information, image information. then you will return this image information to the daemon component. The last interaction is for this daemon to interact with the etc caches database component to input the image information query data. The fourth IFD is inquiring account balance. There are three interactions in this IFD. The first one, the vehicle owner interact with the account balance UI to input the tag information. Then the UI component will input the tag information to the etc caches database component. Also, they get the account balance query output data. Then the UI component will return this account balance report data to the vehicle owner. The fifth IFD is called recharging account behavior. There are two interactions in this IFD. The first one, the vehicle owner actor interact with the account recharging UI component to input the account recharging form data. Then the UI component will interact with the etc caches database component to input the account recharging query data. Here, there has some advertisement. If you would like to read more about this book, then this book is on sale on the Amazon website. You can find the URL, website address on this page. The name of this book is called System Architecture of Electronic Toll Collection, Cloud Application and Service IoT System, written by Dr. William H. Chow. At last, we thank you for your listening. I'm Dr. William H. Chow. I can be reached by this email. Also, you want to know more about the SBC architecture, please go to our SBC architecture website. Thank you. Bye-bye.